In this video I will show you the capabilities of a data wrangling tab. First of all, I have uploaded a dataset which is the CO2 dataset. So we have here the CO2 concentration and the cons column, which is the CO2 concentration in the atmosphere, and we have the uptake of CO2 by the different plants. And now I will change the tab to the data wrangling tab. Data wrangling is the process of working with your data, cleaning your data, maybe normalize your data, and I will guide you through the process of data wrangling. First of all, we have on the left side different buttons. So the first frame is around the variables, and you can use the blue buttons, x, plant type, cons, uptake, to use the entire column, for example of uptake, in an operation. If you want to use the entire data set, then you can use the green button, which is df here. So typical abbreviation df for data frame, and it's a synonym for table. Moreover, you have a lot of buttons for arithmetic operations, you have math functions, you can compare different things. You have also some basic statistical functions like the mean of a standard deviation, and you can also convert types of column. I will guide you through the entire process. On the right side you have here a field which is called operation. It's a text field, so you can type in it, or you can use the buttons. So here I press 4 times plant and it appears in this operation field, but 4 times plant doesn't make sense, and these operations are then conducted, and you have two options. Either you store the result of the operation in an independent variable, so-called an intermediate result, or you append it to your current active data set. Both choices are valid. We will do the following. First of all, we will calculate the mean of the concentration. So I press the mean, and it's already opened a parenthesis. Each function needs its arguments in parentheses. So you press here concentration, and then you press close parenthesis. Now I have to choose an intermediate variable name. Let's call it mean underscore concentration, and then I press run and store intermediate result, and we have here the mean concentration, which is actually also a button, so you can click it. And I can now do the next step. I can now append or normalize the concentration and append a new column. What is interesting here in this kind of structure for the data set is that you have here a table which shows you for each column what type it is. So we have here so-called factors. A factor is something which behaves like a string, or like a string but not like a number, but it's more cheaper than a character, but you can also use here or convert it to character. And we have, of course, here 2 numeric columns, because here we have the normal numbers in it. So what we can do now is we have first to delete the operation, because now we want to make a new one. We say, okay, take the entire concentration column, and then we want to divide it by the mean of the concentration. And now we want a new column. We could call it norm concentration, because we have normalized the concentration by its mean, and we press run operation, and now we see a new column appeared, which is norm concentration. It's of type numeric, because we divided a numeric column, and we divided each entry by the mean which was previously calculated. And now we have here the result for norm concentration. So we only see the first few results, but if we are going back to the data tab, then we can go through the entire data set and look, and we see, okay, we have calculated for each entry of the concentration. You can also do a little bit more, and I will show you in upcoming videos about it. In this video I will show you how you can use the Data Wrangling tab to create new data frames which are subsets of the original one. So for example, you want to choose only two columns. Let's say we want uptake and norm concentration, and we don't care about the other columns. We would use the function getCalls. Go up and we see we have here getCalls. We would use the entire data frame, and when we say okay, I want only uptake, and I would say a comma, and we want, then you list the columns which you want to add. So I will make it a little bit larger, and we here getCalls df uptake norm concentration. And now I would say, okay, of course we have to use it in a new data frame, df underscore new. So I run for operation, and by magic we only have these two columns. If I go now back to the data tab, what is interesting, we can choose now df new, and we see, okay, we have now only these two columns, and we can proceed working with it if it's necessary. But you can also do even more. For example, I now have chosen it, doesn't matter, I will go back and choose the first one, because I want to show you some other things. First of all, let's say the 95 concentration doesn't make sense, so we want to exclude it. We only want values of a concentration which are larger than 100. And we can say, we take here the special getRaws, and in getRaws we also have to use df. Then we say, okay, the concentration has to be larger than 100, and that's basically it. We can call it now df new 2. And if I go to df new 2, it's the upper, then we see, okay, now we have a data frame not starting from 95 but from 175. And if I go back to the data set, and here I choose df new 2, and you see, okay, we deleted all the entries which are below 100. So for these kind of operations, the Data Wrangling tab is also very useful. In this video I will show you how and why to cast the type of a column of your dataset. First of all, I have uploaded the CO2 dataset, so if you have a concentration again, and here the uptake of the concentration by plants. Afterwards, I have created a linear model which describes the uptake and dependency of the concentration in the atmosphere. Now let's assume we want to test whether our data shows variance homogeneity, so I press Levene test. And now we get an error here. Levene test is not appropriate with quantitative explanatory variables. Press again so that can you read the entire message. And what does it mean? So we have here two numeric values. We have the uptake of CO2, and we have the numeric variable concentration. Both are numbers, and the Levene test cannot handle it. The Levene test requires that the x variable, let's call the predictors, are of type factor. So what can we do to test this, or to still test this? So we go to Data Wrangling, and when we say we have here, just to remember you, the type of each column. So what do we have to change? We have to change the type for concentration. This is currently numeric, but the Levene test requires a factor variable or a character variable. Both is sound. So what can be done is convert to factors in this time, and then I have to choose a column. Besides, I have to comment, it is not shown in the video and I don't know how to activate it, but there are hover messages above all buttons which help you and say how you have to use it and which inputs are required, so you don't have to remember all of this. So now you would say, I need the concentration, and you close the parenthesis, when you say, okay, the new column name would be now for concentration, but as a factor. And you run the operation, and now we have here concentration factor, which looks at the moment basically the same, only the digits at the end are missing. And now let's do the following. We go to the Assumptions tab, press the Open Formula Editor, and here we define the same model, uptake, but instead is the dependent variable, but instead of using concentration, we are using our new column for concentration as factor. Pressing create statistical model will now result in a completely other looking formula, and we also see that it's not a continuous increase of uptake, but now we see that each group is handled independently. And now we can run the Levene test on this new model. And as you see here, we have still variance homogeneity is wrong. And this is sometimes it's necessary to do these kind of data wranglings. I will show you another example. For example, let's assume we want to run a test and we have more than 2 groups. And beyond that, we have a more complicated formula now. Let's say we have uptake, but we not only are interested in the concentration, but in addition we want to know the treatment. The treatment is for plants or children, not chilled. So I create a statistical model, and now we have here this more complicated model. Just as you see it here, you have a predicted uptake against the concentration, and you have a blue curve for non-chilled plants, and you have a red one for the chilled one. So with this I can tell you, if we are doing now a test, let's say we want to run an ANOVA, everything will be fine. So I will press ANOVA and it's running in the background, therefore it will take a little bit longer. But what I wanted to show you is, if you are pressing now the Kruskal-Wallis test, it will not work. And that formula should be of a form response tilde group. So you cannot add more than one predictor if you want to use the Kruskal-Wallis test. So what can we do to fix this? Let's go back to data wrangling and delete this. A possibility is that we want, just to remember you, we want the effect of concentration and treatment together. So we could combine them in one new column. To do this, we can use the so-called string function. Where paste and paste 0, they differ in the fact that paste 0 just paste everything together without any new empty space between, and paste needs a separator specified. And it also has some slightly different behavior. But for now, let's say we take paste 0, and then we say, okay, we want concentration, comma, treatment, we close again the parentheses, and we append it. We append it as, let's call it concentration underscore treatment, run operation, append to new column, and as you see, we have here now just combine these 2 columns together. Now we can go back to the test, open the formula editor, choose the uptake as the dependent variable again, but now we only have one predictor, which is concentration underscore treatment. We can create the statistical model. Okay, now we have a complicated model here. We choose more than 2 groups, and now the Kruskal-Wallis test will run and work because we only have one predictor. And this is sometimes necessary if you don't have met the assumptions for the ANOVA.